Hi there, this is a video that's going to introduce energy, which is the new unit we're going to study. Most of this, if not all of it, should be a review from last year from Science 10. Some of you may have forgotten some of the stuff, or it's possible some of you didn't study all this. I'd say that broadly speaking, energy can be split into three different categories. There's potential energies, kinetic energies, and thermal energies. Potential energies are always encompass an interaction between two objects. Kinetic energy is energy associated with moving objects, and thermal energy is this idea of the energy that's internal to an object or a system. So this table goes into more detail. I'll just kind of go through it quickly, and you should spend some time reading it through yourself. There's a lot of different symbols used in energy. I didn't make up the symbols. These are symbols you'd use, and you'll find in different workbook, textbooks, books, websites, who knows. Potential energy, there's two kinds we'll deal with, gravitational and elastic. Gravitational energy is the energy from the force of gravity acting between two objects, and elastic energy is as a result of a spring force acting between two objects. Kinetic energy, again, that's just any object that's moving will have kinetic energy. And internal energies or thermal energies are things like heat, friction, chemical energy, biochemical energy. Like a battery, we would say, would have electrochemical energy. So these are all kind of internal energies related to like the electric and chemical forces that are inside an object, as well as temperature, heat, stuff like that. Three of these energies we have equations for. So we have Eg equals mgh for gravity, gravitational energy. So m is mass, g is gravitational field strength, and h is the distance between the object and the reference point it's being calculated from. Elastic or spring energy is 1/2 kx squared, where k is the spring constant, x is the amount of extension, and Ek equals 1/2 mv squared is for kinetic energy, where mass, m is mass, and v is the velocity or the speed. All of these energies are scalars, which means they have no direction, and they're all measured in joules. Okay, a couple other points to really kind of highlight is when we talk about a system of objects, we say that the total energy in that system remains constant at all times. So, for instance, let's suppose you were going to analyze a system of a ball being held above the Earth, 3 meters above the Earth, and we're going to think of the system being the ball, the Earth. I guess that's about it. At the beginning, it has a bunch of gravitational energy, and if it's not moving, it doesn't have any kinetic energy. But if we let go of the ball, as this ball is dropping, its gravitational energy is decreasing, but because it's speeding up as it drops, the kinetic energy increases, and the total energy will always stay the same. And that's where we say something like this. We say that energy is conserved, or it's also what we call the conservation of energy. The total amount of energy in a system stays the same. So those are the overall kind of big ideas for energy. Next thing I'm going to have you do is go through some, after you've read through those notes, we're going to go through and practice some energy calculations.